続きまして、Getting the most from your OpenStack Cloud、OpenStack クラウドを最大限利用するにはと題し、ファウンダー Canonical Ltd、マーク・シャトルワース様にご講演をいただきます。なお、当セッションでは同時通訳がございます。チャンネル1番で日本語をお聞きいただけます。同通レシーバーがお手元にない方はスタッフがお配りいたしますので、挙手をお願いいたします。それでは、マーク・シャトルワース様、お願いいたします。
That again. Can you hear me? Good afternoon. It's a great pleasure to be here. Japan is one of my favorite parts of the world and has been for many years. I had the great privilege to fly in space 10 years ago. And one of my fondest memories is of looking at Japan and being able to see the country from space, from which it looks really very beautiful. You have one of the most distinctive and beautiful countries in the world. I've also had the great privilege of working recently with a great Japanese landscape architect. And so I engineer as many opportunities to come back to Japan as possible in order to study and to progress plans to bring some of your culture to my home country in the form of a public Japanese garden. So thank you for the opportunity to be here today. And I hope to share some thoughts and some presentations, some ideas about how to get the most out of OpenStack and your engagement with OpenStack. My name is Mark Shuttleworth. I'm the founder of a company called Canonical and a project called Ubuntu. Canonical is the company behind Ubuntu and provides services to people who use Ubuntu at scale. And Ubuntu is an operating system that has become wildly popular with developers, and in particular extremely popular for cloud computing, both on the server and inside virtual machines for workloads. So with that background, I hope to share some of our experience and some of our perspective with you today. For OpenStack itself, last year the question really was whether OpenStack would move into production. And we saw last year the first relatively large-scale production deployments of OpenStack. You can see that OpenStack is gaining traction very rapidly. You can see that OpenStack is moving into production, albeit at relatively small scale, very rapidly as well. We continue to see many institutions running pilots and proof of concepts, but increasingly institutions are willing to let developers access those pilots for dev and test purposes for a period of time before they make their OpenStack clouds available in production. And judging from the inquiries that we receive and the engagements that we have in place, we expect 2014 to be a dramatic leap over 2013 in terms of OpenStack production usage. The companies that are engaging with OpenStack are also extraordinary. Just looking at the companies that are using Ubuntu and OpenStack, we see a full spectrum of the world's greatest institutions. We're very proud to work with companies like HP, IBM, Dell, many telecom carriers, many media companies, and financial companies to help them build OpenStack clouds and move them into production. And here in Japan, for example, I'm delighted to say that we have the privilege of supporting NEC in their work with OpenStack. We believe that OpenStack is the next wave of Linux. And this really is how I think it's appropriate to think about OpenStack as a platform. When you are running an application or building an application for a single server, you talk to the kernel in order to get services from that server. So if you want to launch an application, you ask the kernel to do it. If your application needs memory, it asks the kernel for that memory. If it needs disk space, it asks the kernel to write to the disk. If it wants to expand into more threads, then it asks the kernel for that service. Well, if you step back from that single server and look across thousands of servers, OpenStack plays the role of the kernel for distributed applications. If you're building an application that must run across many servers, How do you launch another thread or another process? You ask OpenStack. How do you get more disk space? You ask OpenStack. How do you get more memory or more CPUs? You ask OpenStack. So you can think of OpenStack in its clearest form as simply an extension of resource management and allocation for Linux across hundreds or thousands, a cluster of hundreds of thousands of servers. Today, most of those OpenStack clouds use Ubuntu. In the last official OpenStack survey that was done with the last release of OpenStack and the results announced at the last OpenStack Summit in Hong Kong, 55% of the production clouds that were reported in the survey were built on Ubuntu. And so a very substantial percentage of OpenStack production deployment is on Ubuntu today. And I'll map out some reasons why OpenStack and Ubuntu go very well together and why we committed early to help make OpenStack a success. The first thing is that we are very well aligned with OpenStack. Ubuntu, the platform, is very well aligned with OpenStack in terms of release cadence, release cycles. We make a release every 6 months of the operating system, and OpenStack makes a release every 6 months. We have every 2 years, so every 4th release, we have a special release that we call long-term support, LTS. So that allows people to plan very predictably which platform they'll have available on which date. And it allows the OpenStack developers to plan very carefully and members of the OpenStack ecosystem to plan for what dependencies they can include in particular applications for OpenStack. We are coming up to the release of our next LTS, which is Ubuntu 14.04, which will be out in April. And so that will be the next major platform release, simultaneous with OpenStack's Icehouse release. Now, instead of just presenting slides, I'd like to try something a little bit challenging. I'd like to actually do an OpenStack installation across 15 servers live on stage right now. So what I'm going to show, what I've set up at my office is a cluster of 16 servers. And those servers have been registered with a service called MAS, for Metal as a Service. And MAS is a simple piece of software that handles physical provisioning of servers. You can use MAS to install software on servers, operating systems on servers, very easily. And it's used by people who have to install lots and lots of physical servers, or who are reinstalling physical servers. So they register the server into MAS, they register the IPMI details typically, and then MAS can essentially install on-demand software. So there are 15 servers, 14 of those are available, one of those is currently being used. These green ones, these 14 servers, they are all available for me to install OpenStack on right now. I hope to be finished with this installation by the end of the presentation. What I'm going to do is use a script which will ask each of those servers to start up, and it will install Ubuntu on those servers. And when it's installed Ubuntu on those servers, it will install each of the components of OpenStack on those servers as well. There are, as you saw in the picture from the earlier presentation, there are very many components to OpenStack that each serve different purposes. So what we've done is we've created an architecture design for these 15 services, specifying where each of those services should go. And this script is essentially placing each of those services in the right place. So what we're using is a simple reference architecture. You can use different architectures with these tools. And you, as an architect, get to decide which services are placed on which server. The important thing is to see that there's no logging in to each server. The process is entirely automated. From the beginning, the interaction with the infrastructure is on an automated basis, not manually installing operating systems, not manually installing software. We're using orchestration at a very high level. The tool that I'm using for that orchestration is a tool called Juju. Now, Juju is a tool that sits a level above your normal configuration management tools, and you can integrate Juju with your configuration management tools. But it's Juju that will give me this picture of all the services that it is deploying on that cluster. So there you see a picture, and you'll see this looks very similar to the picture that you saw earlier from the OpenStack community lead, where he had a whiteboard block diagram of the parts of OpenStack. So the idea with Juju is to give you a very clear picture of each of the pieces of infrastructure that are being deployed. And what this script will do is, piece by piece, it will tell each of those pieces how to link up together. So it will connect the authentication database to the credential server. It will connect the messaging servers to each of the other pieces. It will orchestrate that. And you'll see each of these pieces turn green as that service is automatically configured and as it signals that it is able to talk to all the things that it needs to talk to. So I'm going to leave that for a while, come back to my presentation. We've adopted a very specific approach to supporting OpenStack in our release cycle. You can see that there's a release of OpenStack every 6 months, and we support each successive release of OpenStack on the current LTS, long-term supported version of Ubuntu. So that means you can use 12.04 with any of SX, Folsom, Grizzly, Havana, or Icehouse, and that's fully supported until the release of Icehouse, at which point you need to upgrade to Icehouse. But then we provide the next version of Ubuntu, and we will support the next 4 releases of OpenStack on 14.04. So you can always install OpenStack immediately using these tools, using the current stable enterprise version of Ubuntu and the latest release of OpenStack. For us, that's very important to make possible that people can use the latest release of OpenStack. OpenStack is moving very quickly, so the latest release usually has many advantages. We provide an upgrade path from release to release, and then we'll provide an upgrade path from 12.04 to 14.04 and to 16.04, the LTS releases of Ubuntu. So we want to engage with the enterprise community, give them confidence that they can deploy OpenStack, the latest version of OpenStack on a stable platform, and that they have a clear upgrade path as OpenStack evolves, as it is doing very quickly. Now, Ubuntu has become very popular as a platform in particular markets. Traditionally, enterprise Linux was focused on the Unix workload of being very reliable under a very heavy load on very big machines. Today, the focus has shifted to what we call scale out, which means having very many machines instead of having very big machines. And Ubuntu is extremely popular in that scale out. You may know CentOS. Well, if you look across the top 10 million websites, Ubuntu has now overtaken CentOS as the most widespread platform for websites. And if you look at the top 10,000 sites under load, big sites like Wikipedia and so on, then Ubuntu is the #1 platform for that kind of scale-out computing. It's also the reference operating system for most OpenStack developers. Companies like HP, IBM, and others make very heavy use of Ubuntu for their OpenStack development. So for all of these reasons, Ubuntu and OpenStack go very well together, although we're delighted to have other platforms, SUSE and RHEL, and Windows, coming to the OpenStack platform, because we think to succeed, OpenStack needs to attract every platform, every vendor, every participant. It needs the biggest ecosystem. It is ecosystem that determines winners and losers in platform games. An economic reason for the popularity of Ubuntu is that we focus very heavily on scale-out, large volume, specialized environments like cloud or big data. So because we're able to do that, we can provide enterprise Linux, but at a very predictable price, because we're supporting large volume deployments, because we're very focused on the technology and the engineering and the support, not focused on a sales platform. Most of our sales comes through partnerships, and so we don't have to build up and support a global sales operation. We can focus on supporting Ubuntu and the workload at scale for enterprises that are keen to work in a scale-out kind of fashion. So we have a business model which supports the scale-out and cloud use case as well. I think this is fundamental to the widespread adoption of cloud computing. It's a disruptive change, but it's a disruptive change that is constructive because it brings agility and it brings better economics. And it's the combination of those two things that we think is really important. Giving people agility, developer agility with great tooling, and then also making a strong business case for large-scale computing at a very efficient pricing. One of the things I really love about this culture here in Japan is your extraordinary commitment to quality. And in Ubuntu, our focus is on process-driven quality. So we use two fundamental processes as part of the development of the platform and as part of our integration of OpenStack and Ubuntu. We use continuous integration and continuous deployment. By that I mean that every single time OpenStack changes, upstream or in any of a number of key branches that we monitor, we build out multiple clouds automatically. So you see, with tools like this, we have the ability to build clouds automatically. And so we can run, across farms of servers, we can run an automated process to build and stress and test those clouds. So each change that we make or that others make, we're able to assess how that is impacting on the cloud performance. We also run those clouds ourselves. So we run the current stable and the current development versions of the clouds internally, and we run the majority of our public-facing services on those clouds so that we as a company are dependent on OpenStack's success and dependent on effective deployment processes. And by doing that for both the stable version and the development version, we're able to plan upgrade paths and build confidence in the next version of OpenStack before we ship it to other people. So continuous integration and continuous deployment. Towards the release of OpenStack, we upgrade our own OpenStack in production every day on a continuous deployment basis to make sure that customers who do that will have a positive experience. Part of that continuous integration process is something that we call OIL, or the OpenStack Interop Lab. Now, this is all about making sure that OpenStack works well with components or solutions from a very broad ecosystem of partners. Just like I'm building a cloud for you here today on an automated basis, we can build that cloud using any of a number of different choices. We can build it on hardware from all of the major manufacturers. We can choose an SDN from VMware with Nicira NSX, or Cisco with their NX1000s. We can choose flat networking. We can use the default Open vSwitch networking that is provided as part of OpenStack. And we see additional vendors now joining this program, OIL, so that we can verify that their components can be built in your cloud as well. So using this program, we're able to tell partners and customers which components will work together and what they will perform like for particular kinds of workloads. So it's a very useful piece of infrastructure. It helps us assure quality, but it also helps us support the ecosystem, tell vendors if they have a problem, an interoperability problem between one another. So SDNs, hypervisors, storage solutions, and physical metal, we bring all of those together in one place in our Interop Lab. And just last month, we built the cloud 3,000 different times. So 100 times a day, we're building OpenStack and testing it in different permutations and combinations. The result of that, we believe, is an OpenStack that is carrier grade. Our goal is to get to a carrier grade OpenStack. All of the work that we do flows into OpenStack itself. But we are working with carriers in particular and service providers because we think they are the anchor partners in making OpenStack ready to scale and in turning OpenStack from simply being a product and code into an ecosystem of service providers. So we're very privileged to work with Deutsche Telekom in this case. This is a supporting quote from the head of the business unit for cloud at Deutsche Telekom. But there are a very large number of telcos that are working with Ubuntu to build their OpenStack. Not all of them will share projects at this stage. Not all of them have announced their projects. But we think that you will see a very strong movement towards public cloud provision based on OpenStack, and we are working strongly in support of that movement. I'm just going to do that. See how we're doing. Okay, so you can see over here, this is Ceph. Let me zoom in a little. This is Ceph. The Ceph is a very popular and very interesting distributed storage system. If I go in and have a look, you can see that there are 3 units. We have asked 3 different machines to install Ceph. So of those 15 machines, 3 of them are going to have Ceph running on them. 2 of them have come back and said that they are up and running. There goes the 3rd. Did you see a change? So that 3rd unit has now come back and said, OK, I'm ready to go. You can look at the configuration of Ceph, so you can see how we've configured it, what we've told it to do, which devices we've told it to consume, and so on. And in a little while, you'll see the relationships, the connections between Ceph and other pieces of the OpenStack deployment. I see the RabbitMQ, the messaging server, that is now up as well. So you see that's gone green. And MySQL, that is green as well. The others are still coming up. So it takes a little bit of time to build a cloud. Interoperability, we think, is absolutely key. And there are 2 platforms that we see in very widespread enterprise deployment, which we particularly emphasize in our interoperability testing. One of those is VMware and ESX. We think it's extremely important that OpenStack and VMware are comfortable sitting next to each other in the same environment so that people are able to evaluate OpenStack and get the benefits of OpenStack without disrupting their existing virtualization infrastructure, and potentially so that people can start to consume their existing virtualization infrastructure through an OpenStack API. We think the important battle today is about the API, and so we want to make sure that OpenStack is an API that is useful to people, whatever their back-end preferences, whatever their platform. The other platform that we think is extremely important is Windows for enterprise computing, and so we do a great deal of work to make sure that Windows running on Ubuntu OpenStack is a supportable and high-performance experience for those users. So I'd like to share a little bit of thinking about architecture. I said earlier that we're using an architecture for this cloud that we're deploying here, which is quite simplistic. We've allocated only 3 Ceph units. If you dig in, you'll see that we've spread those services out across a couple of different machines. What is interesting about OpenStack from the point of view of deploying it is that all of the interesting conversations are not about the code, they're about the architecture. What choices you make in terms of the physical infrastructure that you choose, the way you connect it together, the service, the set of services that you choose to build on, because there are always multiple choices, multiple SDN choices, multiple storage choices, multiple hypervisor choices. So that's where the really interesting conversations are. And for us, it's extremely interesting to work with architects, enterprise architects, who are considering large-scale clouds, because they always bring new constraints or perspectives to the table, sometimes very challenging, very specialized network requirements in telco environments, for example, sometimes more straightforward, more adventurous. But those are the really interesting conversations for us and our partners. We think that the core pieces of OpenStack will evolve and will iterate, but that your energy, your interest, your precious resources, your time, your thinking, as you engage with OpenStack should really be at the level of the architecture that you wish to deploy. And the key thing that we think is important is the ability to test and validate your assumptions when it comes to architecture. So again, using the sorts of tools that allow us to model an architecture and then deploy it from a script automatically, any different architecture, different services on different machines, that lets us test and validate our assumptions. We have a game internally between our cloud architects who are at customers all the time, where every couple of weeks we ask one of the architects to come up with a proposition for how to make the cloud perform better. And so we divide the team in two, into people who believe that the proposition will make the cloud perform better and people who don't. And then we actually run the experiment, and there are small prizes. But it's very surprising often what architectural changes, the impact of architectural changes on the performance of the cloud. So this is where I think you really need to invest your time and thinking and engage with people who have had the benefit of seeing many different clouds built up. There are also, of course, operational challenges. Once you have a cloud running, and once you have users for that cloud, you can think of it as a mainframe. Those users do not want to be interrupted just because you'd like to upgrade the mainframe. And so operationally, there are some key things that we think are important to be able to do well. One of them is the ability to do live upgrades of your host kernels. Your host operating system will need to be updated. There will be security issues and performance issues and fragility issues that need to be addressed. So you'll want to reboot those servers if you're not using a live kernel patching mechanism. And your users will therefore have to, they'll either experience a service interruption or you'll have to be able to live migrate them. So this is a key area where we've done a bunch of work to create tooling to automate this process so that you can run a large cluster of Ubuntu OpenStack hosts and then have automatic processes which will migrate workloads away, upgrade clusters, put them through a maintenance cycle, and then put them back into service to carry workloads. Another challenge is that you will want to upgrade the version of OpenStack. So we've been engaged with OpenStack since the beginning, and we have users of Ubuntu OpenStack on every version of OpenStack so far. And inevitably, after a period of time, they would like to upgrade to newer versions of OpenStack. So that's a key thing to think through before you start, is to have a plan for that, how to make that a manageable process. And then also how you'll provide the tools to your users that they need to be productive. You will be benchmarked against the public cloud. You will be benchmarked against the big cloud providers, Microsoft, Google, Amazon. And it's important that the user experience for your users be very positive. So how you provide the guest images that they depend on is really important. The good news is that OpenStack profoundly changes the way you work. Just having a quick look. Yes, looks like we're coming to you. See all the pieces are going green. That means each of those servers is starting to report back that their services are coming on stream. And you'll see the relationships between them form in due course. My key message here, though, is that it's important to realize that as you deploy OpenStack internally, your users will change the way they think about servers. Today, they ask for a server, and then they have a process, or you have a process, as to how to commission that server and bring it on stream. As they get used to working with OpenStack, they want to work in very different ways. They want to automate much more because everything goes up in scale and complexity when you have the speed and agility of instances and capacity on demand. Again, here, providing Ubuntu is a really good way to make sure that people have that agility. Ubuntu, this is a chart of the usage of different operating systems as a guest. So previously I showed you a chart of different operating systems as a host for OpenStack. This is now the guest side. So these are user workloads running on top of a very large US public cloud. You'll see 2/3 of those workloads are based on Ubuntu. So it's very important to be able to provide Ubuntu and Windows to your users and other operating systems. This 20% here is CentOS. This is a service. Scalar is a service that provides a management capability for enterprises so that they're able to see what all of their users are doing on public clouds. And they also report that Ubuntu is about 70% of what's running on the workloads that are running on top of the cloud as well. These are some of the brands, companies that are using Ubuntu in a cloud context, using it for scale out. And in particular, I'm very pleased that we've started work with Pivotal, bringing Cloud Foundry, which is a platform as a service, to OpenStack and to Ubuntu OpenStack together. So you'll need to start thinking about the kinds of services that you want to provide to your users. They will not be satisfied just to get essentially servers on demand. They'll want higher level services from you on top of the cloud. And that ecosystem is only just starting to form. It's a very interesting area of research and development at the moment. But this is the heart of what changes in your life. This is a picture of a fundamental difference between the average company that does technology and the companies that are pioneering the future of technology at scale today. And what this picture represents is the number of servers managed per system administrator. In your average company today, you'll have 10, 20, 30 servers managed by a single system administrator, and people are looking for ways to increase that by small increments. But what we see at the pioneers of cloud computing is an order of magnitude or 2 orders of magnitude difference between the average company and them, Google, Amazon, Facebook, Microsoft, in terms of administrative capacity and administrative reach. They can administer thousands of servers per individual system administrator. And that gives them an enormous operational advantage. And it's that advantage that I think you should be seeking to create for your company. This is the picture you want to see for your company. You want to be part of that group of people that has such extraordinary reach and high ratios of reach per administrator or per developer. So we think that increasingly companies will look to orchestration and automation as the key technologies for their engagement with cloud computing. And it doesn't matter which cloud, right? If you want to become super productive, you have to change the way you engage. So the tool that we think best reflects this culture of automation is the tool that I'm using to deploy this cloud. It's a tool called Juju. Now, Juju in many languages means magic. So it means magic. And Juju emerged from studying the way people deploy complex things on the cloud and then saying, well, we wanted to create some magic that lets them take what they draw on the whiteboard and run it on the cloud instantly. And so that's why Juju looks like this. This is the GUI for Juju, and it's showing you exactly the picture that people would put on the whiteboard and the relationships that people would like to establish between those different services. So this is an example of somebody who's running not OpenStack. This is an example of someone who's running quite a large-scale log management system. And you'll see they've got some very cool modern tools in there. They've got Graphite, which is a visualization tool. They've got Logstash Indexer. So Logstash is a tool that consumes logs from many hundreds or thousands of servers. They've got Elasticsearch, some messaging, bits and pieces of other things. This is the modern view of a management stack. And you can deploy this with a single command on any OpenStack cloud using Juju. So I love I love the idea that in Japan, judo and jujitsu, the ju means sort of flexible or gentle. And so I like the idea that Juju, where I come from, means magic, but here it means very, very flexible magic. And this is the sort of thing that inspires us to enable people to take workloads and deploy them very quickly. So I'd like to show you a little bit of that in action. So this is the canvas that you can work with Juju. And so deploying software is really as simple as just saying, what pieces you want to pull together. So for example, here I might want to provide, let's see what interfaces that supports. Oh, I suppose I can put MySQL behind that. So there I'm going to deploy MySQL, and now I want to build a relationship between those two. And so in Juju, I simply say I want to glue these components together. Those components themselves are open source. And what's interesting about them is that they're open source not just for the code, but also for the operations, how to install the software, how to update the software, how to manage the software. So this allows for extremely productive operational conversations. It also essentially gives you a whiteboard to share. You can have two people say, here are two different ideas for how we could deploy this complex service. So it's a way of replacing the whiteboard with a real experiment that you can put on your OpenStack cloud. But it's even more exciting like that. You can share these things. So I'm just going to find some quickly. Where did I put those? So here are some what we call bundles. And bundles are sort of pre-configured collections of those charms. So for example, here, who's doing continuous integration? Anybody here doing continuous integration? Continuous integration is a really powerful way of helping your developers move much faster. So this is a bundle which you can deploy onto OpenStack that links up all of the key pieces of continuous integration. We've got something called Gerrit, which is a great way of managing code in different branches for developers with Git. Something called Zool, which gates changes. And something called Jenkins, which runs tests. And I just essentially dragged and dropped those pieces, a bundle that maybe a system administrator somewhere else in the company sent me, drag and drop those onto a cloud, and now suddenly I'm creating that service. No logging into the servers, no configuration, totally automated. I can happily show you some more. So here is a large web application. I'll have to zoom out. Here's a large web application. And so you can see I've got Django there, which is a Python app server. I've got Cassandra, which is a large scale-out NoSQL database. And I've got some management tools. So you can see very quickly, you can see which of those services is being managed and which of those services is not being managed. So you can quickly see the connections between all of those pieces. So this allows you, again, to iterate very quickly, to share ideas, try them out, learn very quickly. The fun stuff in cloud is all the workloads. You know, the workload world is changing incredibly quickly. It's not about Oracle databases anymore. It's about React and Cassandra and Mongo. And those tools are themselves changing so fast that it's very difficult to keep up unless you can highly automate your provisioning of those. So I highly encourage you to look at Juju and to encourage some of your smarter DevOps, your developers who want themselves to be driving their own operations, driving their own tooling, to look at Juju as a way of orchestrating your internal operations. We've seen great success with small teams that are doing the same thing again and again and again, automating that and allowing them to be more productive. The best thing about it is that you don't have to change your existing tools. So if your team uses Chef, they can put Chef inside the service definition. If they use Docker, they can put Docker inside the service definition. Salt, Ansible, Perl, Bash, Python, Puppet, whatever your preferred tools are, these blocks can have those tools inside them for configuration management, and Juju will connect them up. So a very powerful way within large organizations to connect up good work from different groups who've chosen different tools, as they do tend to do. Okay, so this is our OpenStack cloud, coming to the end. This is our OpenStack cloud, and you can see lots of relationships established. And this over here is the dashboard. So this is what we call Horizon. And Horizon, you can see it's connected to the authentication system, the credential management system, and so on. So I'm just going to go and have a look. I'll tell you, it'll tell me where Horizon is. I'm just going to go have a quick look, see if I can spot where the dashboard is. Here. So let's see. It's not quite up yet. And I think I'm just about out of time. Okay. It'll come up, and I'll be glad to show you. Our booth is just outside. You can see all of the relations are established here, but the pieces have not yet settled down and started talking to each other, so the dashboard hasn't come up just yet. There we go. Let's see. Sure. Right. So just in time. Just in time. This is OpenStack. Now I'm just going to do that. So this is Ubuntu OpenStack. You saw it installed from scratch, from bare metal. There was nothing running on those servers. All you need to do that yourself is to take 10, 15, 20 servers, install Metal as a service, MAS, register each of those servers to MAS, and then use one of these architectures or one of these automated scripts together with Juju to build the architecture that you want. And we'd be very happy to help you with that if you want to test different architectural ideas and benefit from the exposure that we've had elsewhere. So you can see, just very quickly, you can see this cloud now has been configured to have these different kinds of instances. And I'm just going to launch some instances. And so you'll see, if I go into the project here, you'll be able to see that I've spun up a bunch of working virtual machines, or they will come. There they are. So these are now working virtual machines that have been spun up on top of that cloud that we installed in 35 minutes. Right. One last thought. OpenStack needs your participation. You know, it's a very vibrant project. It's enormously energetic. It is a focus for energy and activity from many, many vendors. And your voice is important there. It is an open project. I say this every time I talk to OpenStack developers, that what's also important for OpenStack is focus. Right now, everybody wants OpenStack to do a little bit of everything. And in time, it will. But there are some key things for us to get right now. And one is to define the core of OpenStack, just like we define the kernel, and make sure that we keep that very useful so that it can stand us in good stead for many, many years. And then let us innovate everything else. Everything else we will change, but the kernel is extremely difficult to change. So I like this quote from Albert Einstein, who said, anybody can make something more complicated or more violent, but it takes real genius to go the other way. All right. I hope that was helpful. I hope that was useful. I'd be very happy to discuss your OpenStack interest further, and we're just in there with all of the other booths. ありがとうございます。
マーク様、ありがとうございました。